Welcome to the second lecture of Unit 7. In this lecture, we get to know the major phases on how to realize a concentrating solar power project. The project implementation topic will be divided in two lectures. The first lecture deals with the initial project phase and procurement phase, and the second one covers the execution phase and operation and maintenance phase. It is my honor to make this presentation and to bring in my experience to this work. I am a mechanical engineer and have been working in the solar business for the last 13 years. Since January 2010, I am acting as an AMENA project manager at the German Aerospace Center. So we start the first lecture on project implementation now, where we will have a closer look at the project initial phase and its subsection, site selection study, pre-feasibility study, conceptual design study. This lecture includes also the typical project procurement steps, pre-qualification, request for proposal or the RFP, bid documents and guidelines, and finally bid evaluations and contract negotiations. Here you can see an overview of the main implementation steps. As mentioned already, this lecture will cover the first two phases, initial project phase and the procurement phase. As we start the project implementation topic, we have to know that the flexibility level to define and design is larger at the beginning of a project than in the later project implementation phases. So subsequently, it is very important to have a sound and solid feasibility study and conceptual design study to ensure that the big investment of this project is spent in the right way. In this diagram, we can see that the project expenditure increases over project development advances, and subsequently the possibilities to interfere to reduce the project expenditure goes down with the time. The first action in the project implementation process is normally selecting a site, which is done by a study called the Site Selection Study. This study has the purpose to select the most suitable site for the proposed CSP project. In many cases, we think about a solar master plan in which a pilot plant will be constructed in the beginning in a dedicated site. The level of details of this assessment study is just to cover all key selection criteria. This depends on the quality of information received about the site. I will come back to this later in the next slides. The time required for such study is typically between 2 to 3 months. These are typically figures and could vary depending on the site, country, utility, and level of development of a project. And the scope of the study covers the site visits to get to know the site itself. Very important to conduct a solar resources assessment. The assessment of required and available infrastructure, the evaluation of land characteristics such as soil and subsoil conditions, topography, etc. The topography defines immediately if the site is suitable to host a CSP power plant or not. For example, the slope of the land is vital parameter for the definition of the technology that will be implemented. The elaboration of site assessment reports is also included in the site selection study. And finally, a ranking of the assessed sites using a selection matrix should be performed. On this slide, we can see the site selection criteria to be taken into consideration. First of all, the solar resource should be considered. In particular, the direct normal irradiation, the DNI, should be analyzed since we are talking about CSP project. We know that solar irradiation is fluctuating over time, not only daily but also weekly and yearly. Therefore, we need a long-term and precise meteorological data for that site to ensure that the economic and the future power plan is planned soundly. We can compare these given ground data of the site, if any, with satellite data from these resources. The infrastructure is the second backbone of the site selection study. It includes the grid connection analysis that includes not only the capacity but also the primary and the secondary response criteria. How strong is the electrical backbone of the electrical network? What are technical requirements of the fluctuations of the CSP plant in case no thermal thermal storage available. All of these must be taken into account. Site access is an important issue. Water availability should be considered, especially when wet cooling is considered for the power block. In case of combined backup fuel availability will be tackled. The availability of telecommunications medias are also important for the operation of the power plant. And last but not the least, the land characteristics are important. I have already mentioned the topography, but also the size of the land is important. If we speak about solar energy projects, the space requirements compared with conventional power plants are much bigger. Moreover, the land coverage and usage must be analyzed. The geomorphology and natural hazards should be analyzed too. Finally, the visibility and air pollution at that site should be analyzed. For example, if there is a mining nearby that will cause the increase of particles in air that decreases the sky clearness, which is an obstacle for the erection of CSP power plants that depends on the direct normal irradiation. Similar to that, if oil fields or factories are operating nearby, this affects the erection of CSP power plants and the operation of them, of course. Now we take a look at the pre-feasibility study and its scope. So the sense for the pre-feasibility study is to get for comparably little amount of money the first idea about technology, about the selected site, and the economics thereof. The purpose is investigating the general applicability of CSP power generation in the area of interest in order to have a basis for the decision to proceed with the project or not. The level of details is preliminary assessment for several project options with different technologies. The aim is to narrow it down to one technology which is feasible for that particular site, indeed. The time required, again, it is a general statement, could be shorter or longer, but it is typically 2 to 4 months, depending on number of assessed technologies, configurations, and proposed sites. So the typical scope of a pre-feasibility study is, again, site assessment, if this not covered by site selection study. This would be also re-evaluated in the pre-feasibility study to check out the decision made for this site, by the way. The general technical description of applicable CSP technologies and, of course, the configurations will be included in the scope. A preliminary technical design of considered project alternatives will be given, with the startup and shutdown principles, with the duration of operation, the particularities, the situation for competitiveness of the equipment supplier of these technologies, the EPC and their availability. So all of these will affect the price. Moreover, the study includes the first performance modeling of project alternatives. Performance modeling means that you have to calculate the annual power output of the power plant using the solar data and the various technologies. The study includes also a preliminary cost estimates. So we're talking about CapEx and OpEx broken down by main items in order to calculate the levelized electricity costs. This gives an answer about the competitiveness of your CSP technology for the taken site. Normally, a preliminary environmental analysis is also included in the study. This should give an idea about the environmental impacts from the power plant, for example, how much fuel will be burned and how much CO2 will be emitted into the air. Also, the impact on surroundings, for example, if we have air cooling that could be noisy, etc. These topics should be at least touched to get a full picture. Here, a socio-economic study should be also performed to some extent to indicate the changes the power plant would make, for example, to create more jobs, since it is labor-intensive, and more relating topics. A SWOT analysis, strengths, weakness, opportunities, and threats should be carried out in order to indicate how attractive is the project alternative. And finally, outlining the project implementation structure and implementation schedule is important. The time for such project means money, and on their turn, the lenders and shareholders want to ensure that time is short for executing the project. Now we take a look at the feasibility study, which is the next step towards the implementation of a CSP project. Of course, the level of details of this study will be higher from its name now, but the scope of the study will stay the same as that of the pre-feasibility study. Moreover, in the feasibility study, the procurement strategy, either EPC or IPP project structure, will be decided. If the decision is made for an EPC structure, a conceptual design study should be performed by the EPC contractor. I will come to this later, but now let's go through the characteristics of the feasibility study. So the purpose of the feasibility study is in-depth investigation of the most promising project configuration. Only one option is considered in the feasibility study, not like the pre-feasibility study, where we get to analyze various alternatives and technologies. In the normal process, you define the technology at the very beginning of the project feasibility study, and then you will be having a more detailed look at the economics and technology, because there are often constraints and interfaces. So the level of details is sufficient to receive bankable report. In the last lecture, we learned that there are two types of project financing, the corporate and project financing. In any case, there will be lenders, and these have a vital interest that the project is so-called bankable, because these are bankers. And subsequently, the feasibility study, if considered to make the final decision a kind of go for the project, should have the output that the project is feasible and bankable, because the economics considered in parallel to technology options and constraints. So the typical duration required to conduct the study is 4 to 6 months. Again, it is a general statement. It could be also shorter or longer. This depends also on the level of details in the pre-feasibility study. Moreover, you could overlap other studies in this duration. For example, the conceptual design study to gain time and ensure a smooth project development. The typical scope of a feasibility study covers normally the following points. Firstly, the site assessment. It is important to do this in more details now in order to avoid any surprises during the implementation. Specific technology description and design calculations will take place. You will have certainly to calculate, for example, the heat and mass balances of the power plant and to produce single-line diagrams. All these technical details should be available in the study. Also, a layout of the plant besides some arrangements of large equipment should be included too. The study should indicate also the procurement of these equipment. The performance analysis, including design optimization, will be done again. The better your solar data are, the better your economics will finally be. Herewith, you can better evaluate the risks of your project. The cost estimate should be done also in this study. Often, EPCs will be asked for quotations. What would be the rough price or the capex for the procurement of such a project? Depending on the level of details, you would speak, for example, with suppliers of steam turbines. The study will analyze whether the techno-economics considered are feasible. The availability of procurement slot will be analyzed in the study as well. It will also check if there is competition. Definitely, you'll speak with several suppliers to control the costs. Finally, it ends up after a cost estimate, in best cases supported by a bid in a technical economic model, which is not the final financial model of the project execution. It's a kind of early stage of analysis, what the costs in the project are and when they occur over the project duration. The risk assessment is vital. Risk assessment and bankability are close to each other, and there are plenty of risks to be analyzed in these cases. The environmental analysis should be done with more details in the feasibility study, more than in the pre-feasibility study. This will indicate the value of the project as well as environmental impact by executing the the project. Finally, the study will have to include information about the project implementation. The scope of the feasibility study is demonstrated here in more details because of its vital importance. On the left-hand side, you can see the items we already highlighted in the previous slide, and on the right-hand side, you can see more description about each item. So we start with the site assessment, which includes further detailed assessment and verification of findings and results gathered during the pre-feasibility and/or site selection study. It includes also solar resources assessment using bankable D&I data and development of typical meteorological year, P50 and P90 dataset. It is very important to have a sound basis for your project. The technology description and design calculations will include general technical description and selection of all main equipment and systems. Here you will find the heat transfer fluid, for example. The solar heat exchanger shall be precisely calculated in the feasibility study in the case that the solar heat exchangers are the interface between two different EPCs, which is the case sometimes. The preliminary design calculation will be included also in the study, for example, the heat and mass balances. And finally, a description of operational aspects should be prepared too. This also is very important in this stage. During the feasibility study, a close relationship with the off-taker, the transmission company, should be established to understand better their particularities. For example, to what extent the overhead lines could be shifted, whether the plant can evacuate power, what the specifics are in back energizing if the project is close to be commissioned. All of these topics have to be analyzed in order to have a full picture of future problems. Come now to the performance analysis as part of the feasibility study. It is done by using a special CSP performance software tool. There are plenty of such tools. Often companies have their own tools. These tools are based on solar data, for example, D&I data, which should be calculated precisely depending on the time stamp, normally 10 minutes or sometimes hourly or whatever, in order to have the base for the performance calculation of a day with the particularity of starting up and shutting down. There will be power losses to be taken into consideration. Moreover, you have to ensure that you are not too optimistic in which you use various data sets in this regard. These data sets include the probability of solar irradiation. This is important because your plant will be directly linked to the solar irradiation. So based on a data set, hourly resolution, for example, the performance will be calculated. It is important that we calculate the gross and the net generation. The island mode operation principle should be known. You have to know also the own consumption by giving a list of the main consumers to better understand to which extent the plant will be available in case of failure in the overall network. Now, cost estimation. Based on the preliminary design mentioned above, the cost will be estimated for the main equipment and subsystems. Breakdown by main systems, including equipment, transport, erection, and commissioning costs. The scope of the feasibility study includes also the technical economic evaluation. It is based on performance analysis, cost estimate, and financial constraints. All of these will be considered in one techno-economic model. It's normally an Excel-based tool where the elaboration of detailed cash flow takes place, and the performance of sensitivity analysis will also be included. We know this in the conventional power plant sector, in which we vary fuel price for operation. In the CSP field, we vary the likelihood of the D&I occurrence at the particular site in order to see where the risks are allocated. Speaking about the risks, a risk analysis should be also made. This should cover not only the major risks, but also mitigation strategies, including general and financial project risks, as well as technology and site-specific risks. This ends up in a risk matrix giving a full picture of pros and cons. This matrix will help you at the end to decide if the project is too risky feasibility or feasible. The environmental analysis will include assessment of environmental impact during construction and operation. So it is not only during the operation, for example, by considering a blow in supplementary firing or a leakage of the heat transfer fluid, it is also during construction. The environmental analysis of a feasibility study would normally include an assessment of an environmental impact during construction and operation. It is not only during the operation, for example, by considering a blow in the supplementary firing or a leakage of heat transfer fluid, it is also during construction. In the environmental analysis, an early hazard analysis is normally done. This analysis includes also determination of environmental benefit. In this regard, the avoided CO2 emissions, for example, should be determined. Finally, this analysis does not replace a detailed environmental impact assessment, which is due in later stage. Finally, the project implementation should be considered in the feasibility study. It defines the project structure and implementation schedule. We spoke about two different project structures, the APC and the IPP structures and their impact on the implementation. Also, it conducts an assessment of proposed project financing. There are various types of financing, even within the IPP model. This topic must be addressed in this stage and includes an assessment for the required licenses and permitting process. The conceptual design study should be done in case the procurement strategy of a project is decided to have the EPC project structure, because it's client's obligation to analyze the techno-economic constraints on behalf of the future bidder, in this case the EPC contractor, and to define it properly. What are the technical requirements? What are the operation requirements to be considered by the EPC? In case of IPP model, this study would be easily skipped because in this case, the level of details in the tendering document is normally less than this in the EPC model. The reason for that, we have seen it earlier, is to give more flexibility to the developer bidder to optimize its plan by considering most suitable EPC and operation and maintenance options. So the purpose of the conceptual design study is to give further specification of the technical concept elaborated in the feasibility study to have the level of details as required for the technical specifications of the request for proposal documentation or RFP. The time duration required is normally 3 to 5 months, depending on the level and also the maturity of technology design. The typical scope of work includes normally revision and specification of site assessment, conceptual design of general layout of the CSP plant, including interfaces, conceptual design of the solar field, conceptual design of the heat transfer fluid system and the thermal energy storage, conceptual design of the power block and balance of plant, conceptual design of the electrical and INC instrumentation and control systems, detailed operation and maintenance concept, revision of performance analysis, and revision of final assessment. Now we go into more details about the project implementation phases. The time schedule for the procurement phase starts with the RFP preparation that lasts for 3 months. Request for proposal preparation normally includes the request for proposals. It defines performance-based technical specifications. It sets transparent, open, and fair tender rules and bid evaluation criteria. It drafts bankable model of the power purchase agreement, PPA, because the developers have an interest also to know what is the governmental framework package for the entire project. The pre-qualification process will be also triggered here. The bidders or consortia who meet acceptable threshold levels based on technical capability and the track records will be qualified, and rules will be established for maintaining pre-qualified status. In this phase, several bidders will be willing to qualify to participate in the bid. Therefore, you need to put rules to evaluate the eligibility of each single entity to continue in the bidding process. The eligibility rules are therefore very important in this regard. The next step in the procurement schedule is the preparation of the proposals that is also called tender phase. This lasts typically for about 4 to 5 months, but this could be shorter too. If, for example, the power purchase agreement was already prepared, there will be a pre-bid meeting with the bidders. A site visit will be offered for them, and their clarification will be answered in this phase. The preparation of proposals ends in bid opening. The bid opening session has various types depending on the content envelopes that are included. We will come back to this later. So normally in the submission and opening of proposals, a deadline of submission is very important. So late proposals will be rejected. A bid bond, generally 2% of total project budget, shall be furnished as part of the proposal. The validity of the submitted proposals is important and is normally shall be defined to be at least 1 year after the deadline of submission of proposals. The next step in the procurement phase is the so-called evaluation and selection of best ranked bidders. In this stage, a compliance test is made. The requirements of the tender documents will be compared here with the bid received. Based on this, it will be determined whether the proposal is compliant, whether it is complete, and whether the eligibility and the qualification criteria of the contractors and subcontractors are met. This is done normally during the first week after the deadline. An initial evaluation will take place also in this stage. This will be mainly based on price criterion. It means who has given the lowest price. I want to highlight the need for transparent process here. The evaluation criteria should be absolutely transparent. The more the transparency is, the lower will be the risk that bidders are ranked not like they believe they deserve to be ranked. Therefore, tender documents, not only technical but also legal and commercial, should be as precise and transparent as possible. So during a month, initial bid evaluation will be finalized and written clarifications will be sent out to the bidders, typically after 10 days, addressing major concerns, deviation from standard tender documents, and other issues. Then, a meeting for clarification will take place prior to ranking of proposals. The detailed clarification and evaluation stage commences right after this, as client's board of managers decides to go along with the first ranking bidder. Then, detailed clarifications on commercial, legal, and technical issues will be discussed with the so-called best ranked or successful bidder. Clarifications will be addressed in the power purchase agreement, EPC, and O&M contracts. This takes around 1 month. The final evaluation of proposal will take place. Meanwhile, you will still send out some clarifications to second and third bidders to ensure keeping them on track for the case to be flexible if the negotiations with the first ranked bidder fail. So after about 1 month, the so-called winning bidder will be identified. And depending on the project, in another month, the project documents will be precisely defined, including all relating technical and commercial appendices to form a sound set. Finalization of these contracts will be done by signing them. In this stage, the project company should be already registered, as it has to sign the EPC contract at the effective date with the EPC contractor. In the upcoming months, not necessarily 6 months, could be also less, the financial closing takes place, in which the bidder has to submit development bond, the bidder has to comply with the conditions precedent. This is a kind of defined term. Normally, at the financial closing, the bidder or the EPC contractor will be asked to bring in some items, for example, the Environmental Impact Assessment Report, the EIA, because the lenders would like to ensure that there is no risk related to environment because the signature is put on the power purchase agreement. Here I would like to highlight the single aspects in the procurement phase. On this slide, I will start with the objectives and process of the pre-qualification process. So the objectives of the pre-qualification process are to inform likely bidders about important aspects of the project, to convey seriousness of intent to pursue, to initiate process of consortium formation, and to ensure that only serious and capable bidders will participate in the bidding. The steps are done normally by issuing of invitation to pre-qualify, here to identify and invite likely interested parties such as developers, utilities, EPC contractors, operators, etc. Mass media could be also used to advertise intent and maximize competitiveness. The steps are also done by establishing criteria and rules. Here you have to establish and share criteria and selection process in request for qualification to maximize interest and transparency, and to establish rules for maintaining pre-qualification status. Preparing request for qualification, or RFQ, is also included in the pre-qualification process, where the RFQ has to include the project information, criteria, selection process, and deadlines. A nominal fee will be requested also to limit distribution only to serious applicants. Finally, the pre-qualification process ends up in pre-qualifying the bidders. This means the candidates who meet the minimum thresholds of the pre-qualification criteria will be eligible to continue with the bidding process. There are mainly three categories for pre-qualification criteria. Firstly, the financial strength of bidders, in which credit rating and historical financial performance, size, leverage, and profitability will be considered. Secondly, the criteria for the IPP experience, for example, the IPP's development track record, experience with CSP, project management skills, and regional experience. And finally, the extent of consortium formation will be investigated. Bid documents and guidelines are normally one set of standard documents for all bidders to guarantee the bid evaluation in a fair and efficient manner. These standard documents are prepared normally by project advisor, who normally use their own tender documents. Contract templates and guidelines are also part of the bid documents and are available from, for example, International Federation of Consulting Engineers, multilateral, regional, and national agencies and development banks, such as the World Bank, the African Development Bank, or the KfW. Finally, the national regulations and laws relevant to the bid should be considered in the documents. The bidding procedures could be a single stage with one envelope, a single stage with two envelopes, a two-stage with two envelopes, or a two-stage bidding procedures. Typically, there are 5 parts of request for proposal documentation. The general instruction to bidder, so-called ITB, outline the specific procedures and requirements for preparation, receipt, and opening of proposals, evaluations, clarifications, regulations, and so forth. Secondly, the general technical specification is a huge report with hundreds of pages, includes a description of the minimum requirements and the scope of work for the solar power plant. Then the RFP documents include also the bid forms. They are a set of all form sheets, basically technical and financial information, but also performance guarantees to be filled out by the bidder based on the bidder evaluation criteria. Drawings and diagrams required for bid preparation will be also included in the document set. This could include the baseline report of the environmental impact assessment, the EIA, that is carried out before. Finally, the drafts of EPC, PPA, and O&M agreements are also included to enable the bidder understanding the given project factors. So the content of request for proposal documentation could be seen here on this slide. In part 1, again, more details about the general ITB are given. So here there is an introduction to the project, brief background information for bidders, so an overview of host country including electricity sector, general legal and regulatory framework in that country, could be included. A project description is also included in this part, including major technical and commercial features, agreements, and implementation schedule. Guidelines for proposal preparation, for example, deadlines, period of validity, tender, opening, and confidentiality, and bid security. This includes also procedures for selection of bidders. So we are talking about evaluation criteria and process, etc. And finally, procedures for shortlisting bidders and award will be included in this part. Part 2, the general technical specification, includes normally the following items: scope of the CSP plant, the project facilities, for example, civil, mechanical, electrical, instrumentation and control, description of site preparation requirements, etc. It includes the interfaces, so we're talking about grid connection, backup fuel supply, etc. This includes also the site conditions, very important here, for example, the solar radiation, the design requirements, for example, capacity, availability, grid connection, codes and standards, etc. are included. Also, the inspection and testing, description of training program, and finally, technical documentation required for bidders will be delivered. The request for proposal documentation includes also some bid forms, such as letter of conveyance, bid security, legal form of bidder, eligibility and qualification of contractors, design and performance guarantee data, project cost estimate, total budget, operation and maintenance costs, financial data, such as sources and uses of funds, debt equity, terms of debt financing, cash flow statement, debt service coverage ratio, proposed electricity tariff, project implementation schedule. It includes also technical data, for example, information on main features and equipment, vendor list, etc. And finally, declared deviations. Part 4 includes layout drawing of site and infrastructure, basic data, so site investigation report, topographical survey, solar data file, etc. It includes also general, mechanical, electrical, and I&C drawings and diagrams. Finally, it includes information about ordered long lead items. The last part 5, includes normally the following draft agreements. We're talking about power purchase agreement, the PPA, including calculation of payment. It includes also shareholders agreement, the EPC term sheet, the O&M term sheet, and finally fuel supply agreement if this applicable. The procedure of bid evaluation should be transparent as mentioned and will be based on non-price evaluation criteria for financial and technical aspects. For example, the level of project development, financial viability, equity return considerations, the most relevant technical aspects, practicability, and project implementation schedule. For the ranking of the proposals, only proposals that are considered to be substantially responsive will be considered for evaluation, i.e., they meet the requirements of the tender documents. Normally, the price criterion is the driving factor in the ranking of proposals. The last slide of this lecture gives an overview about the contract negotiation. The ranking procedure ends up in a short listing of 2 or a maximum of 3 bidders. Negotiation with first ranked of the shortlisted bidders takes normally place, and we keep the second and third bidders in case of unsuccessful negotiations with the first ranked bidder. Detailed clarifications on commercial, legal, and technical issues take place also in this stage up to the finalization of the power purchase agreement and the finalization of other contracts such as engineering, procurement and construction, and operation and maintenance contracts. And finally, signing of these contracts and the registration of the project company. Now we come to the end of part 1 of the project implementation, therefore end of this lecture. Thank you very much for your attention.